Molarity is a little bit different from some of the other units used for concentration because it is not a percent. It's a calculation of the moles of the solute divided by the volume of the solution. So remember, moles, we can determine that. We can either calculate that from the grams of solute, convert it into moles using the gram to mole conversions, or we might know the moles directly. The volume of solution, we need to know how much of that solution we have in liters, and it's specifically in liters. So the moles of solute for every exactly 1 liter of the solution. This is extremely useful when using balanced equations. So we're going to use this, and it's going to be really important for stoichiometry involving solutions. There's also a simulation that's available showing how molarity works, how that relationship works between the moles and the liters. So let's take a quick look at an example. So how much 6 molar hydrochloric acid in milliliters would be needed to completely react with 0.92 grams of zinc? Now this problem is going to combine a whole bunch of different calculations that have been done throughout the course. So what do we know? We know that there is 0.92 grams of zinc, and we know that we have 6 molar hydrochloric acid. What we need to know is we're going to need to know what our balanced equation is. So we're going to need to know the balanced equation because we're trying to go from one compound to a different compound. So remember, if you are dealing with 2 different compounds here, you're going to need a balanced equation to convert between them. And we're going to need to also make a plan. So if we know the grams so I'm going to first look at our balanced equation. So this is the balanced equation for zinc reacting with hydrochloric acid to form zinc chloride and hydrogen gas. Now we need a plan. So grams of zinc is what we're starting with, and we're going to need milliliters of 6 molar hydrochloric acid. Grams of zinc, but we can't use that balanced equation unless this is in moles. So we're going to first convert our grams of zinc to moles of zinc. So remember, using our molar mass of zinc. Then we're going to use our balanced equation to go from moles of zinc to moles of HCl. So that's going to be using our balanced equation. Then we can go from moles of HCl to liters of 6 molar HCl using the molarity. And finally, we can go from liters of 6 molar HCl to milliliters using the relationship between milliliters and liters. So we know that for 1 milliliter equals 10 to the negative 3rd liters. So this is going to be 2, 3, 4 different steps. Okay? So let's take a look. So first we're going to find our moles of zinc. So we know the starting grams, and we can find the molar mass from the periodic table. So if we look on the periodic table, the molar mass of zinc is 65.38 grams per mole. And remember, we can write it as this is 65.38 grams of zinc for every 1 mole of zinc, or in this case we can write it the opposite way, just 1 mole of zinc for every 65.38 grams of zinc, because this comes from this equivalency. The 65.38 grams of zinc equals 1 mole of zinc. Okay? So we're using that to create our conversion factor. I'm going to put this over 1 so that we can clearly see that the grams of zinc are canceling. And we get about 0.014 moles of zinc. So that's our first step here. So now we can take our moles of zinc, and then we're going to convert that into moles of HCl, the next step. So we're going to use the moles of zinc in the balanced equation to find the moles of HCl that's needed. We have our balanced equation. So from the balanced equation, we can see that we have 2 moles of HCl for every 1 mole of zinc. So 0.014 moles of zinc times 2 moles of HCl for every 1 mole of zinc. Moles of zinc are going to cancel over 1, so it's clear. So we need 0.028 moles of HCl. So we're going to use that. And now we're going to use that molarity to get from the moles of HCl to the volume of HCl that we want. So we're going to use the moles of HCl and the concentration of HCl. So remember from the problem, it was 6 molar HCl. So 6 molar HCl means that I have 6 moles of HCl for every 1 liter of solution. That means I have 6 moles HCl equals 1 liter of solution. So that's my equivalence. So I can write it as 6 moles for every 1 liter, or 1 liter for every 6 moles. I have my 0.028 moles of HCl from the previous. My moles of HCl are going to cancel, and my solution, I have 0.0047 liters of HCl, so that's 6 molar HCl. Okay, so that gives me my liters of HCl. The problem wanted milliliters though, so now I can convert the liters into milliliters. So I have 1 milliliter equals 10 to the negative 3rd liters, or 1,000 milliliters, 1 liter. We're going to use this conversion factor. Either one will get you the same mathematical answer. So I have 0.0047 liters of HCl. I'm going to multiply by 1 over 10 to the negative 3rd. My liters are going to cancel out, and I get 4.7 milliliters of 6 molar HCl. I know it's a lot of steps for this type of problem, but if you track and label very carefully, then you can make sure that you are including all of the steps and doing it very precisely throughout.